contact, avoid contact, 100% keen and modulation is go. 4, 3, 2, 1.
Yeah, thank you. Thanks for the kind introduction. Welcome to track 2 of 2, or 1 of 2, not sure, but at least you found the way here, so that's good. Yeah, as Cloud mentioned, I'm Wolfgang from the AppMon test automation team, and together with
Bernd from the OneAgent test automation team.
We will talk about our transformation from schedule-based builds to commit-triggered pipelines today. So first of all, since most of you are from the company, but still a few external folks, let's introduce a bit what we actually do in the test automation team. So we like to think that we live in search of the Holy Grail. So for the older folks among you, Monty Python, the British comedy crew, yeah, our Holy Grail is the green CI. We like to live in a world, or we like to imagine a world where there are no broken builds, all the tests are working all the time, all the tests are green all the time, hopefully. So we try to make that happen. So we maintain our build scripts, we maintain our CI environment, we maintain the build configurations, and we provide test frameworks and tooling around that building for the developers in our company. So to just outline a bit what we're dealing with, try to fetch a couple of numbers in the preparation for this talk. So how many builds do you think we have per day in our AppMon CI environment? Maybe a question more for the people from the company. Do you think it's 100? More? 200? 500? Any other guesses? 1,000? 10,000? 1,337. That would be a very good number, actually, yeah. Or 42 maybe, but actually it's around 4,000, so which surprised me as well. Couple of more numbers. We have about 80,000 tests that are executed per day, at least for the AppMon part of the company, which is one of the products that we build in Linz. We have over 200 CI machines that we use for building and testing our code. What we build is around 800,000 lines of code, of native code for 9 different platforms, and about 2 million lines of code for Java, which impressed me quite a bit. So. And what we want to do is we want to make continuous integration great again, as a bit frowned upon today, but we want to make it usable as a tool and not as a burden for the guys in our company. So what we're actually striving for is we want to reduce the cycle time for commits to something below 15 minutes. So we want to reduce the time it takes for you to get feedback whether the commit that you made broke something or is impacting other people, or whether everything works. And we want to be able to provide that in a reliable and fast manner. So that means we have no flaky tests, and no flakes that just, no snowflakes that toggle between red and green without any apparent reason. We don't want your code to be affected by other people's changes, compile errors, whatever. And we also want to avoid any effects by infrastructure problems, even though Marcus is now not listening, but yeah, they are not happening. No. So we want to get to Planet Green CI. So we really adopted that space theme. Who's inhabiting that? Where our Holy Grail is hidden? Of course, Martin Fowler. Probably everyone heard of that guy, the famous continuous integration book, who stated that everyone commits to the mainline every day. So continuous integration is all about making sure that your code works in combination with the code of the other people in your company. So you're supposed to integrate regularly the stuff that you build with the other code that's being built in the company. So it's especially important as the team grows, because broken builds or stuff that doesn't work affects more and more people. But it also gets harder, since there are more commits, there are more people to interact with, so the probability that something goes wrong just increases. So another big question is, how can we get there to our planet with our nice little spaceship? So of course we could just cruise over, but there is something in between, the monolith. What is that? So let's just dive a bit into what we mean by our monolith that we want to break up, as Klaus outlined before. So again, an old movie. I like to think about me as that one, but yeah, maybe it's also Stefan in the back. So our monolith is about rebuilding everything all the time. So it was started a couple of years ago, and it's just one big build that is taking everything that's available and building it from scratch all the time you're executing something. So you can imagine that takes a while to get done, but it's rebuilding it all the time. What it also means, it's a bit fragile, since if everything is rebuilt, you get a lot of changes in there that might have not been anything that you care about. So you're getting a lot of potential side effects from other people's changes that are made. Since it has grown over time, it's taking longer and longer. There are more tests being added. The code base is growing. That's sand, so not that something, no, sand. So it's a big pile of stuff that keeps growing and growing. And it has that nice vintage feeling about it, since it was started 10 years ago, something like that. So we're using Ant as the main build tool, which is configured in a lot of XML files. So it's very fun to work with and a very great technology. So it has that nice MapController Orion feeling to it. But we're dealing with it, and it works to the most part. But still, we feel that we need to improve a bit on that. So let's just outline a bit how the life cycle of a commit looks like in our current environment, simplified a bit, but still for the sake of this presentation. So you commit something, there's a build being kicked off, and we deal with about 8,000 tests that take about 4.5 minutes. So after that first stage, in the commit stage, we have some other unit tests that have been executed. They test bigger blocks of code, so that's why they take longer. We talk about 4,000 tests in about 15 minutes. And if those are green, there's the smoke test stage where already an Appmon server is started. We start other components to make sure that data is being sent correctly, data is being processed correctly. That takes about 15 minutes, and we have a whooping 4 tests in there. So you can tell that at about 35 minutes, you should get a pretty good feeling if everything is okay with the stuff that you changed. At least to be able to make a statement, I didn't break anything that really affects other people in a very bad way. So we have 12,004 tests. But that's only a very small fraction of the actual tests that we have, or the total number of tests. So if you look at our overall integration tests, we have 160,000 test executions. So that's already for a couple of days. I think it was a week. So pretty good number. But you can tell here, let's round it up to 40 days. So the last half minute, I think we can deal with it. Last half hour. So it's obvious we can't execute all of them on commit, because if we can only commit every 40 days, it would be a bit boring in the company. So with our current approach, we figure out build problems like compile errors and stuff like that pretty early, but it can take rather long for functional problems to actually come up, because if the tests are only running once in a while, mistakes are prone to stay undetected for quite some time. So we want to change that, we want to improve that. So now if everyone is supposed to integrate to the mainline every day, which takes, as we said, 35 minutes. If we have 100 developers, 100 times 30 minutes, that's still possible in a day, but it's already getting a bit tricky. And if anything goes wrong, it takes even longer. So obviously with that monolithic approach, it's not really possible to stay with that. So now there are a couple of things that we could do to improve that. For example, we could build in parallel. That's also something that we don't really want to do, because it's a bit fragile. You don't know why stuff breaks if something goes wrong. It's typically a bit slower because there's more stuff happening on the same machine. And there are some side effects that are possible from ports being occupied, temp files not being cleaned up. So building in parallel is, it can work, but we don't really want to go down that route. Another way would be using more virtual machines. So where is Sarah in the back? We know what your hamster is doing all the time. We use a lot of VMs in our environment, but typically, while they're great for provisioning, we found that they are slower than physical machines. Obviously, sometimes builds take up to 3 times as long as they do on physical hardware. And with the shared resources, it's also always a big difficulty to find out why things go wrong, like slow I/O performance, high CPU usage, and so on. So while VMs are definitely a great tool, it's not really the silver bullet that we were hoping for or looking for. So what can we do to ensure fast and reliable feedback? What do we want for that? We want to be able to build changes independently from other developers' changes. Obviously, there's only one reason to be able to do that. We need branches, which is not really new technology, a new concept. Bernd will talk a bit more later on. So now in our current environment, it's very hard to use branches. I think is Mike Kuma here? He got one branch a couple of months actually ago, and it's really difficult to configure that, to maintain that, to make sure that also tests and builds are running on the branch in our current environment, CI environment. So we need some kind of automation around that to be able to use more branches and use them effectively. So automation, yeah. And since the monolithic build doesn't work that well with branches, because as we've established, it's not the fastest, it's not the most agile technology that we're using here, it doesn't really work that well in parallel. We need to break up the build into smaller bits and pieces that we are going to call components for the sake of the argument. So we want to break up our build to make it fast and to be able to run it in parallel. So what we want to do is we want to make it as hard as possible for you guys to break the build. So kudos. We want to establish a workflow where you can test and build the changes independently from your own machine, because it's very hard if you want to do everything locally. Takes long, you're blocked from doing other work if a machine is executing integration tests all the time, so we want to be able to do that somewhere else. So, of course, we need CI support for development branches. And now I'm going to hand over to my sidekick.
Yeah, I'm the junior partner of the presentation. So currently, all our source code is based in one big subversion repository. It basically works great. It's not the fastest, but we have over 700,000 commits in there, and it's still working and working and working, and basically not that much problems with that. But when it comes down to we want to be more agile on branching and whatever, it comes down to the fact branches are only copies in Subversion, and there's no semantic behind that. You can do any copy of any folder in there, and you would get your branch, but it's very hard to automate around that stuff, because how to check or how to provision something there for having builds or whatever. So simply, we will have our problems with Subversion. So what could we do? We know we want to have a workflow where we have branches. We want to push on the branches as much as possible. And maybe we also want some verification there. So there's one little tool around which some small projects in the open source community already used it. We could use Git. For Git, we now have the features there that branching is a first-class citizen. You can have branches, you have great tooling support for them. Depends on the tooling you are using. You can also create your branches out of your issue tracking system. You can directly combine your branch with your Gyro issue there and whatever. So you have great tooling there. There's also support for directly triggering CI builds, whatever, on pushes on your branches. And there are the great features which comes along with Git and all those servers. You can use pull requests. You can use pull requests as real quality gates, so you can make it sure that your build is passing, everything is fine, and even so, one colleague can do the code review before you are submitting your stuff into the main line and maybe change some unwanted behavior to something uncommon or something breaking or whatever. So for us, we decided by Subversion, we will do something newer, something better for us. But what comes around there is we don't want to change only the tool. We also could just switch to Git and use it as before. Having one main line, everyone is supposed to push the changes on that main line, and we would only invested some time for migrating to something new and not having those great benefits on our CI system. Of course, some developer would be happy to have his local branches, but all in all, for having a faster, reliable CI, which is providing more feedback, we have to definitely change our workflow there. Yeah, for the workflow. So there are two features which are going to be developed by one or more developers, and the guys are creating branches. The guys have their own branches and can do whatever they want there. They can push as much as possible there. If the build breaks, no problem at all. No other guy gets influenced there. So if you imagine, we have about 100 developers who want to integrate very commonly on the source base, and we have a red build there. All those guys are blocked and their changes are not tested until the build gets green again. If we give every guy their branch where they can do whatever they want, no problem at all. They only get feedback on their branches, and until the tests are red, the build is not passing, you simply have no chance to integrate back to master, but you are sure that you won't harm anyone else besides you. So we have our gatekeeper here, which is providing something bad coming up. And if you don't get your build and don't get your pull request and your reviews as you should do it, you won't pass. And it will provide us a master which is green nearly all the time. Of course, you can have some troubles with infrastructure. Of course, there can be 1 or 2 flaky tests, but I'm quite sure all the folks which are influenced by that, you will get your perfect feedback quite fast and quite immediately. On the other hand, if you break something, no one cares besides you. So we don't have to send or to turn on our great email generator if something bad happened on some CI build, and you get emails, you get tons of emails about, yeah, there's a build broken with a change set of 10 guys with 300 files, and you have to find out what happened. So, looks quite great. But now we have found our version control system, which we want to use, but one small thing is missing. It's great to have Git and have all those branches, but we need someone or something which can provide us the builds there. Our very customized, homegrown, not mainstream CI server may not be the best choice, since we would have to have all those automation about creating branches for the Git creating branches in the CI server for the build by ourselves. So we had a look if there is something around there, something new, which could help us there. And then we found out there's a guy who can serve us the Holy Grail for free. With Jenkins, you create your branch in Git, and you will get your remote branch or your build branch in the CI server for free. It's only they are working perfectly together, no problem. You have your build immediately, where you only see your changes in there, and everything is fine. About the problem with VMs are sometimes slow or whatever, we have the great function that we are quite open to every technology which comes around, which Markus will tell us later, about dynamically provisioning machines we currently need for our builds. So if we don't need some virtual machine, some Dockers, some whatever fancy stuff is around, we don't have it running, and if we need it, we will provision it directly by Jenkins, and everything is fine. And last but not least, nice benefit, currently, if we are configuring CI builds and talking about CI builds, there are those magic teams which are doing something magic which no one knows what really happens there, and from time to time the build turns green or red or whatever, and no one knows how the build was configured and how this stuff is working. With our new approach, the build is also part of the code. The build is checked in with all the source code files. It's tracked down. It's visible for everyone what's happening there, and even the developers can also do some changes to the build, and they are tracked all the time. So basically, quite good for the test automation guys, because developers can do our work so perfectly. Now I hand over to my senior partner.
I'm not sure who is Batman and who's Robin.
I'm the sidekick.
Okay, so now we have a great plan. So now the question is how can we put that into action? And when we were looking at our code base on the monolithic stuff that we talked about before, there was one project that was just standing out because it was added quite recently, and we wanted to give it a try to separate that out into one of those pipelines that we mentioned now. And of course, we ended up with our web UI, or as we learned, it's called AppMon Web, So we decided to go with that. What is it? It's a web frontend for our tool for the AppMon server. It's based on the Google Web Toolkit technology. That's what I wanted to say. And it was already built with keeping it as a standalone component in mind. So there wasn't a lot of effort involved with having to separate it out of the big code base, because it was already built in a quite good fashion to be able to rip it out and put it somewhere else. Just a couple of numbers on the web UI, because I liked making those slides. Again, it's around 130,000 lines of code, 70,000 lines of JavaScript, 4,000 plus unit tests. So kudos to Stefan and the team to keeping that number quite high. Consists of 9 different projects, built in about 5 minutes, and supports 4 different browsers that are supposed to be tested in there. So if we talk about a component, what is that? As I assume most people have some background in software engineering in here, I think it's shouldn't have to talk too much about that, but just to cover all of our bases, what is a component in software? It's something that can be reused. It's loosely coupled to other components in the system. It's a reuse-based approach, so you have a standalone thing that you can also use in other places. You can reuse it in other projects, for example, and it's all about separation of concerns. So a component should not be involved with fiddling around and all over the code base and being all over the place, but it should just take care about the one thing it was built to cover, which is, of course, key to finally getting to our holy grail. So what that means is bye-bye monolith. We want to get rid of rebuilding all the things all the time, because if we know what changes were in the component, and if we're only dealing with individual components, we don't have to rebuild everything when we know that something changed. So we got rid of that. It's also hopefully becoming more stable, because if we have less changes in there, we're not getting a lot of changes from people that I don't care, changes I don't care about, not people I don't care about. I love everyone. So we're getting rid of that. And it's also a smaller piece of code and piece of software that we're dealing with. So it's not the big pile of accumulated stuff that we talked about, but it's just really narrowed down to the actually relevant tests and the actually relevant source code in there. So what's the big thing about components? They need to interact with each other, so we need a stable API that has to be defined, that has to be maintained. We need some kind of versioning, so what we went with, at least for AppMon Web, is the semantic versioning approach. So that, I think, works quite well there. We need to define ownership in some way, so who is responsible for a component, who's allowed to do things like defining the API, changing the API, extending it. It can be built and tested independently, so it's not dependent on any other parts of our source code. And the ball of text rest. It needs to be self-contained and self-testing. So what that means for us is that the artifact that comes out of one of our component pipelines is self-tested. We know that it works. We know that other builds that are run afterwards are only getting versions that are known to work, so there's less chance that something maybe snuck in there that's not supposed to happen. And it can be tested alone without any effects on the server or on other parts of our system. So how that looks on the screenshots, we didn't dare to do the live demo, but we took a couple of screenshots of our Jenkins pipeline that we built for AppMon Web. So we have only 2 branches, unfortunately, our master branch and one of the feature branches here. We see that they are both feeling quite healthy, so everything went good in there. When we look at that, we see the individual pipeline steps. So we build at the beginning, we have some unit tests running, we have some UI tests that are executed there. Then we have our quality stage where we're running static code analysis using Sonar. And at the end, if it's on the master branch, we want to publish the artifact to our binary repository. We're using Artifactory here. So at the end of the pipeline, the resulting artifact that, as we said before, is known to work because it has been tested, is published so that other builds can again consume it and reuse it. And ideally, not stage, but actual screenshot, all 4,486 tests were passing, at least at the time. We're not quite there with our under 50 minutes goal. We're at 70 minutes here, mostly due to the quality stage, but we need some room for improvement. It would be boring if everything would already work as we wanted to. So now we have arrived on our planet, Green CI. Now we can have developers work on features independently of other people's changes. They can go in, experiment on their branch, have CI coverage there, and once they feel that it's ready, they can merge it back into the mainline and provide the changes, make them available to other people. So you can integrate them without affecting anyone else. You're not risking a lot because you know that the changes on your branch are already working. And the result of the pipeline is an artifact that's known to work, as said before. So tests are actually executed when the changes are made and not at some point later when the build or the test is scheduled. So that's a great improvement from our perspective because we can make sure that the tests are really covering stuff that is fresh in your minds and not happening a week later or so. So what are the challenges that we are still facing? Of course, those component APIs and the dependencies are a bit hard to define. So you have to make sure that you get the APIs right, because if you change them afterwards, it's still hard for the consumers to stay up to date. Also finding the right size for the components is a bit difficult. Shouldn't be too big, shouldn't be too small. So again, it's a bit of experimentation and also experience that we still have to gain with figuring out what's the right size for a component. And the whole topic around versioning and dependency matching becomes more important because there are many ways for folks to stay up to date with new component versions. So how are you even aware that there's a new component version out there? How can I make sure that nothing, no breaking changes are happening there? And at least from what we've learned so far, there's no really predefined right solution that gets it right all the time. So again, that's still something we're working on. That's why it's on this challenges slide. On more tooling-related things, Git is supposed to be more complicated than SVN. That's also why we have the Git user guide on here. And the build logic that we have currently scripted in our CI server is rather hard to migrate. So we have a lot of Groovy scripts in our current solution. We want to avoid that vendor lock-in in the future. So one of the major challenges for our teams is migrating that scripting logic that's in there and put them into build scripts or some other places so that they're reusable for different solutions and for Jenkins, obviously. So what are the next steps for us? Of course, we want to further drive the componentization of Atmon. So we want to keep on working with that topic. We want to move on with defining suitable components. So based on the responsibility, for example, if you look at our backend server, there are things like the correlation engine, the session storage, and so on. So there are a lot of individual bits and pieces that can be broken out, but we will need a lot of effort from development teams for that, obviously, since redefining those APIs and making sure that we can build those components in a reusable way is something that we can do on our own. Of course, we want to make sure that we can add more tests to the pipeline so that we're able to identify issues already on a branch and not after we have merged to the mainline. And what we also still want to achieve is less spamming for broken builds. So I think some people might think that for every of the 4,000 builds I mentioned before, they get 1 email per day. So that's something that we, of course, want to make sure that's not also happening in the future. So that's also one of the goals that we have. Okay, and with that, we've come to the end of our presentation. Still have a lot of time left for questions. So thanks for your attention so far. And yeah, please let us know if you have any questions that we can answer now. Thank you.